we are trying to figure out, well, we're doing two things at least at once. One, trying to figure out what's wrong with how we are doing slurping. That is funny term. How we are controlling how fast the zombies can rotate when they're facing the direction they're walking. Mainly to keep them from like when they're passing, like quickly flipping back and forth and looking really weird. And so we had some initial code that was AI generated that didn't quite work, and we've been trying to understand how to properly do this. And honestly, if I wasn't so stubborn, I would just like look for some things that other people have done to do this instead of just trying to figure it out on my own. But what's the fun in that? I feel like we've touched on a lot of interesting things this way. And then the other thing that's going on is that we spotted a bug, and let me double check something. I could have asked AI to do this as well, but I feel like there might have already been an issue about, let's see, dialogue? No, okay. Guess there's not. Great. Okay, so this is not going to be a duplicate. So we saw a bug where the tutorial dialogue from the first scenario stayed open even if we exit the scenario and go back to the main menu. So I asked AI to write up a bug case, and it has a bunch of ideas about what the problem might be, but that's fine. We're just going to let it go do its thing. And there we go. Cool. Okay, so back to this though. What I want to think about here, so we have this rotation speed, and we have like rotation interpolation speed for smooth turning. That's true. And we tried to turn this up to like 10,000. I guess let's see what that does. That should be the equivalent of doing the thing we had before, where we just use the target direction instead of interpolating, because that should cause the weight of that we're passing to slurp to be clamped to 1.0, and so that should use the target direction. I do have a thought though around defining what are the units of that setting, right? Like what is 1 or 30 or 100 or 10,000 actually represent in terms of what the enemy is doing, right? So we have, let's see, free scrap, unlock all tech. If I unpause the game and I put yeah, it doesn't look like he's turning at all though, is the thing. So like if I put some obstacles here, he's still facing this way. He's not turning. Do we? I have a couple of thoughts. One is still defining what rotation speed is. 2 is having some kind of indicator of what those vectors are. So we can do like a debug line to show those things. Right, so we have global target look position and global current look position, and we could draw those lines. So we could draw all three, right? So we can say use debug line to visualize all look positions. Yeah, okay, so we're not actually going to use a project setting. This is just temporary. Get node. No, we don't want to do that. We want to, we can definitely just instantiate. There we go. So we want to do debug line current look position. So we take our current position and then where we're going, where we're looking, we'll set a width and a color. Let's not do... So that'd be red. Do we have handy methods? Color. That's not what I'm looking for. Color. This one. Constructors, methods, operators, constants. There we go. So we have constants that are all uppercase like that. Is it not debug line 3D? Debug line? Nope. Line? Is this, is this not built into... Maybe it's an extension. Debug Draw 3D. This is an add-on for debugging drawing in 3D and for some 2D overlays. Yeah. I think this is what I'm looking for. So we'll download that. It's going to put this into add-ons. It's going to provide examples. Can we... So we don't want examples. Very good. Let's go ahead and install that. Okay, and then it told us that we need to reload the current project once we've done that. Yeah, I know. We have problems. So there we go. All right, we need to add it to the project settings. Plugins. No. Not there. And add-ons. README. Been a long while since I've opened this view in Godot. Installation. Close editor. Copy into add-on. Create folder if it doesn't exist. Launch editor. Okay, so let's just save and quit. And we'll just do a hard reload of Godot. It's interesting that opening the project in Godot also shows this splash screen. Not something I was expecting. So if we go to project settings and we go to plugins, it's not there. Kind of weird. Close editor, copy to your add-on, create a folder doesn't exist. Launch editor. Yeah, debug draw 3D. Oops. Yeah. Sure. I don't know. It seems kind of confused. Does it exist or not? Well, just so it says fail to load script. So with the parse error, so it seems like maybe no. Yeah. Cannot construct native class because this is okay. Great, cool. I'm confused. Open on online docs. Okay, so debug, draw, 3D Godot. Debug, draw. Okay, so asset library. Okay, great. Maybe I should look at. You have a link to your repo. I can just look at the add-ons. That's fine. Add-ons, debug. Let's go here, and then yeah, I could have looked at the examples, but why would I do that? So debug draw 3D draw line is what we're after, not what we're doing here. So global position target. We don't want red. I think we're gonna go with aquamarine. Aquamarine. It's not happy with me, but I wonder if this is a stale. Remember the time I clicked this and it had a reload? Anyway. Okay. Output. Yeah, it's just out of date. Okay. Hey, there's a restart. Reload from disk, sure. Okay, there we go. We have a debug line. So here we go. What does this line tell us? What does this line tell us? Okay, so this line is the line to the global target look position. So this is the line for where we want to look at. Which is really interesting. Because that seems wrong. Okay, how do we... Global target look position is the next path position, but Y is set to the global, like where we are, right? So we're not looking up or down. And then we normalize, so we make the vector of length 1, returns the result of scaling the vector to unit length. So global target look position should be a length 1. So what does draw line do again? We close the tab. Line path line with arrow. Okay, this may be a this may be a me issue. You know, it'd be cool. Do you have? Why is there? Surely there's a like a GitHub page, right? Oh, here we go. Why is there not a link to it? In fact, there's a website. Hey, examples, and then to draw line. Sure, but what does, besides the name of the method, what do the things do, and how would I know that? Okay. Not helpful. Examples. Well, I suspect these are not going to be helpful either if they're not telling me, okay. What is the difference between draw line and the other ones? Guess we read the source. Oh, it's not in there. Ooh, what is the difference between line, line path, and line with arrow? There's interactive web demo. Okay, these are lines, apparently. What kind of lines are they? Add text to... Okay, no. Not telling me information that I would need. You would... Yeah. Something's not adding up here because... Obviously, these aqua lines are not of length 1. Draw a line from A to B. Color duration. Okay, let's get rid of duration. Don't know what that is. Maybe that's the problem. Okay. So when we're drawing a line, is it drawing a line through 2 points? Well, that can't be... I'm assuming this is 0, 0. Like, I don't understand. Let's do this. Let's do my logger info. Let's just dump. This is going to be a lot of text, but I don't know what to believe right now. Oh, I did the thing. Go away, tutorial. I meant to load the test scenario. Okay, so right. Actually, that makes total sense. Except not really. No, like current look position, target look position. Target look position. Is that what we're logging here? Global target look position? But it's not a global. Right. I think I understand. Yeah, this is wrong. I understand why now. Okay, so the issue is this normalized for one thing. Because that doesn't make any sense. Because that would only make sense if this was a direction vector, but this is a position vector, right? So the reason the global current look position is a unit vector is because we calculate it by taking the local position as a unit vector, because it's model front, and converting it into global coordinates. No, that's no. It's, yeah, never mind. The thing I just said is not true, which is unfortunate because I think I said it a couple times, right? But this is a position that happens to be a unit vector because of how we constructed it. When we convert it into a global position, it is no longer, it's in global space, it's no longer a unit vector because it contains the coordinates in 3D space in global coordinates to what we're looking at in local space. For this to be a unit vector, we would need to take the difference between this and, how do we do that? Well, it just can't be a global vector, right? It no longer makes sense as a, it's not, yeah, it's just the wrong kind of unit. What if we worked in local coordinates? If we worked in local coordinates, then we could keep the vectors being unit length vectors. And then we convert the local coordinate into a global coordinate to look at, because look at takes a global position, right? Once towards the target position, calculated in global space. Yeah. So I think we can do that. So what we do is we get rid of this. Then we make a local target look position, like so. And this becomes local and local. I'll get rid of all the logging because I don't care about that. Just ignore this error, it's stale. This gets us a global position, global target look position. Is that useful? Can we, I guess what we can do so what we need to do here for local target look position is we need to do 2 local and then normalized. Does that work? No. Well, yes. So a local vector means that the 0, 0, 0 of that is where we're at, and so it's not just a position anymore, but it's also a direction. If we normalize it, it's a normalized direction. And then what we want to do, we get to make this work, what we need to do is then we need to take a local target look position and be like 2 global to convert it back, to have a line of length 1 from where we're at to the direction we're going. So specifically, this is a line for the targeted look position. Okay, that is a lot of things, and maybe that makes sense. But this is why why I wanted the debug lines. It's hard to keep track of all these things. Okay, so first of all, I don't see a bunch of aqua lines anymore. That looks really good. Let's accelerate time a little bit till we see a few zombies. Okay. So take this one for example. We don't. Oh, there's the line. Look, it's a unit length line. Amazing. So if I give myself all the things and we do this, yeah. See, they instantly respond. Very good. Very good. The pathing could be better, right? But theoretically, see how it's flipping back and forth? That's because the rotation speed is so fast. Okay, we're getting somewhere. I have a thought. So if we go back to this, can we? Hold on 1 second. I want to check something. Is there... Are there settings? Yeah, good. Okay, so now we have a separate set of settings here for our debug line. So we don't have to worry about having conditional checks in the code. We can just turn that off. Okay, cool. Great. If I want to actually include the add-on and like checking in. Which, given that things are working, maybe I don't. Anyway, it seems like things are working. Yeah, I probably just need to close VS Code and reopen it to make that go away, but it's fine. I can ignore it. So what is the unit here, right? So what are so let's do it this way. Rotation speed is in degrees per second. I don't think that's true. So let's do this. Let's what is a reasonable number here, right? So if, oh yeah, I meant to do something else. So if we go to project settings and our, wherever the physics settings are, here we go, 3D physics or common? Might be common. Physics ticks per second, 60. Okay. So the delta value should be 1 over 60. Which you'd think, you know, okay, so 1 over 60 is 0.016666 repeating, right? So if we have a value of 100 here, that's about 2. If we have a value of 10, then we get 0.166. So another way of thinking about this, right? So the unit here for rotation speed is, okay, well, I think we work backwards, right? So what do we do with rotation speed? Rotation speed times delta is a value between, or it's clamped between 0 and 1. So delta is, well, how do we calculate what delta should be, right? If things are going optimally, we're calling this every physics frame, and we're doing 60 physics frames a second. So delta is 1 over 60, where 60 is the number of frames, and 1 is seconds, so seconds over frames. If rotation speed were 60, then this value would be 1, right? Does this make sense? What makes sense as kind of a thing to set? I think what we want to do is we want to say, that's interesting, because that sets this up right now. This rotation speed value is essentially a number of frames? For what? How many frames before we fully get to any position is kind of weird. Is that right? Regardless of how big the rotation is, right? The way this is currently working is that no matter how big the rotation is, we traverse it. I mean, how big can the rotation be? I mean, really, half of a circle, 180 degrees. How many frames does it take to turn 180 degrees or less? It's interesting, right? Because this, I mean, we're not doing angles. We are interpolating between two different target positions that would be, because they're unit vectors. They're aligned from the origin to the unit circle. Math. So we're not really setting, we're setting like a maximum speed or a minimum speed? I guess a maximum speed. A max rotation speed. It's kind of weird. I guess what we want to do is we probably want this to be relative to the distance between the 2 points. Although the difference in the unit vectors is not quite the same thing as the arc, like the length of the arc. This is why slurping the rotation would maybe make this cleaner. I don't know. So what does it look like if this is 10? This is one of the things that can be, I mean, I guess in a way this whole stream has been an example of, hey, this is a cool thing about writing code, is that you can actually, you can see it in practice, see what it does. I took away the debug line, right? Okay, so anyway, here's the next zombie. So if I put how does your rotation change over time? Oh, that's fun. What is going on? Okay. Okay, so 10 is way too small. What about 100? Wait, how did a zombie get right? Okay. I guess the spawning area is the whole map. So I guess it's possible for a zombie to spawn, like, right on top of them. It's unusual, though. Here you go. So do you... When your line changes... Yeah, we got some, okay. Doesn't seem very responsive. So 1,000. Yeah. how's this supposed to work? I don't know that I want that rotation speed there. Let's think about this a different way. So really what we want to do is we want the weight of how we're interpolating from is this even the right thing to do? Like, I think we want to interpolate, but we don't need to... Like, everything makes sense here except for this part. So if this was 0.5... Now, this is not great because this doesn't take into account, like, how... If the frame rate drops or increases or whatever. But if we just do this, and so every physics frame we interpolate halfway, this is probably too much. But I think ideally I would anticipate that with this change, we would see the change in direction happen immediately. Very good. Put it back to 1x and then pause, unlock everything. So these guys are walking along, and we can drop some obstacle in their way, and they like they don't reorient. As much as I would expect. Like if I change your pathing. I mean, maybe it does. Maybe that's fine. Why is your pathing not changing? Yeah, I think there's definitely some opportunities to do things with the way we're doing pathing. There we go. See, Let's try to get ahead of a few of these over here. So you are going this way, but you're not turning to face that way. Why? Like, you can't be moving this way, following the line, unless, you know, the call to get the path is actually getting that direction. But local current look position interpolated. Oh, right, but this is slurping. Oh, right. So we needed to convert this back to global, right, to make this work. We need to do two global. There we go. That's a thing that we're missing. Let's try again. If at first you don't succeed, iterate 1,000 times. All right, where's zombies? Okay, so get out of here, Steam. Yeah, I have a hotkey that's supposed to disable notifications. I think it's that one. I forgot to hit it. That. So when I started, I did remember today to put Discord into streamer mode. And the other thing I was thinking of when I did that was I should turn off notifications. That didn't work anyway. And I didn't do it. Anyway. Okay, so moving on. Hey, look, that immediately works. Great. Okay, so that's the real problem with this. Okay, so 0.5 means that we interpolate halfway every frame. So So really, if we think about a variable called movement amount as being here, this ping at 0.5. Get hold on. You left me no choice. Exit Steam. Get out of here. 0.5. Okay. Right. So the unit here is yeah, that autocomplete was not helpful because of course it's thinking of the word unit in terms of like the enemy, right? Movement amount. The unit of this variable is arbitrary, isn't it? No, it's sometimes AI autocomplete is not helpful at all. Trying to think of a word that I want to use here. It is essentially the total rotation per, not second, but per frame. Total rotation is a maximum of 180 degrees. So if we want it to not be per frame, but per second, then we have to multiply by delta, right? Because delta is seconds per frame. And so if we have a unit that is essentially, wait, is that right? Divided by delta to multiply it by the inverse, and then the frames cancel out. And then it's the amount of rotation per second. Maybe this works if we go back to divide this by delta. Divide or multiply? Divide doesn't seem right. Let's think about this. So if this is 0.5 per frame, but we have 60 frames a second, then it should be this value times 60. So this should be 30, right? And this would be times delta, which should be 1 over 60, which should be 30 over 60, which is be 0.5. Okay, so then I'm just working backwards to put this back where it was, right? It's not movement speed. It's a different value. Unit is maximal rotation per second. So if we wanted this to actually be degrees per second, then we would need to multiply it by 180, and we divide this number by 180, right? Does that make sense? Or am I thinking about this backwards? If we want to make a, yeah, it's kind of weird because we're not constraining the rotation by how much we're rotating. We're just saying you can rotate any amount as you want, any amount you want, as long as it takes this amount of time. Which is interesting conceptually of like, if you need to make a smaller turn, it takes as much time as turning all the way around. It's weird. I think what I'm going to do is I'm going to just make a constant right above this. Const float. Not that. I don't know what that's supposed to be about. Time to rotate equals 0.5. Is that right? No, 30. 30 what? Still not right. Still all over the place. Time to rotate is wrong. Right, it's I mean, that's right, but it's definitely wrong. Expected initial. What do you mean? Const. Oh, right. This is a different language. It's like looking at that. That's right? Syntactically, time to rotate is not correct. Rotation time in seconds is also not correct. So if we have 1/60, 60 frames. Why is it okay, it is. I mean, 30 is right because that gets us to 0.5. But what is... It's not time to rotate. Is it... This is a case where we essentially have a magic number, and I'm trying to find an intuitive way of describing what this value is. So what I'm going to do here, now we have a magic number that when multiplied by delta gets us a value between 0 and 1. The problem, there are many problems here. All of these things are wrong. If every frame we wanted to instantly think about this. So every frame, the amount we want to rotate, the proportion of the rotation. What is the proportion of the rotation? So how does slurp work again? Result of spherical linear interpolation. What does spherical linear interpolation mean? It's really interesting. It's interpolating on a sphere between these two vectors, essentially doing an arc, and these are both unit vectors. So we are traversing an arc of a unit circle then. And so if we it kind of feels like what we want to do is the weight is amount of interpolation. It's weird. I probably am really just overthinking this. Rotation, speed. Why is that taking so long? What are you doing? What are you doing, Vasco? You're scaring me. What are you doing? Okay, I give up. Go away. That should never take more than like a sec. Like we're renaming this. Okay, cool. Great. Wait, does screencast mode not persist through Guess it doesn't. Also, okay, cool. I'm confused. Why does F2 not work? It does nothing. You ever have that feeling where things just don't want to work? Rotation speed is what I was gonna temporarily put here every single day. Yeah. It's like suddenly things aren't working the way you expected them to. So what it feels like I want to do here is I want the weight of the slurp to be relative to the I want to, what am I trying to say? I want the value that we're using, that we're passing here, to be in some way proportional to the length of the arc, right? Because right now it's not. We're just saying, hey, some time has passed. Maybe I need to think about that in those terms, right? So if we say rotation speed is, yeah, let's do it this way. So let's put this into unit terms and then figure out how to make that happen, right? So if what we're saying is the 0.5 value is every frame, every 60th of a second, we were doing half of whatever see, the thing is they were tiny rotations, right? So let's say how long should it take for the enemy to rotate 180 degrees or pi radians? I think it should take 5 seconds to rotate pi radians. 5 seconds. So it's not radians per second, it's seconds to rotate pi radians. Okay, so boy, where does the time go? It goes to me slamming my head against math over and over again. Okay. So the problem is doing this. What is... Can we do that? Local current look position, angle to local target look position. Angle to, does that return radians? Excuse me. Unsigned minimum angle to the given vector in radians. Oh, that's handy. And this works because they're both local. So the origin is where we're at. They're both the same place. So what is the arc, right? And then so that's number of radians. Then we have rotation speed, which is seconds per pi radians. This should maybe No, this should let's just make this seconds per radian. Yeah, okay. And then this should be times pi, right? Or over pi. I guess it should be over pi, right? Dimensions. I mean, it's literally 5 over pi, right? That means every second you're rotating wait. Right, we want this way, right? So we want to say this is 1/5 of pi. So every second you rotate 1/5 of pi radians. So it's really radians per second. Right? Okay. So this is radians per second. Radians over seconds. What is the bar elapsed? Okay, so what would this be? So this is rotation speed, which is radians per second, and then delta is seconds per frame. So then you have radians per frame, right? Because you're multiplying, you're canceling out numerator and denominator. So you have this. This is where I should pop up like a scala draw, and we'll draw things like yeah, whatever. Just imagine. So you have radians over seconds. You have seconds over frames. So seconds cancel out, and you have radians over frames. So how many radians are we going to rotate? And then what we want is the fraction of radians that we are going to slurp. Because we have radians to target, right? So then we have var rotation fraction. And this should be unsigned. So whichever direction we need to go into is the only thing that's important here, right? And then we just use rotation fraction. That's how much we slurp. Okay. So what do we think? I mean, radians to the target can't be negative. It's unsigned. So this is not a thing. Stop trying to make it a thing, Copilot. Okay, here we go. Now, did this break everything? Zombies, where you at? Oh, there's one. Okay, so free scrap, unlock all tech. An obstacle. Hey, it turns, and it turns fast, but not too fast. Like I might want to make it turn a little faster. And in fact, so now I'm gonna take this and we're gonna bring this back to the top, and we're gonna be like, hey, this is actually an export. Export rotations var rotation speed. Except it's going to be, we're gonna take this down to like every 2 seconds. Might be too fast. 3 seconds. And then what we're going to do is we're going to try to rename the symbol. Rotation speed. Okay. Sure. Cool. Okay. We're going to give this one more shot, and then I need to go see about getting some lunch. So we will wrap up shortly. Figure out who we're gonna raid. Okay, zombies. We didn't get to any kind of modeling today, nor did we get to any kind of shader stuff today, which is not the plan. But hey, we made a page with a bunch of links in it in the project repo. Yeah, thank you. I hope it'll be good. Okay, so let's see what this looks like. Yeah, look at that. Okay, he could path better, right? But he quickly turns without like. So see how the path oscillated back and forth? Well, what happened before is that he would face back and forth really fast too, and that doesn't happen anymore. Okay, and that was the thing we're trying to fix. So we did it. And on that note, I am going to go over here to source control. We are going to delete rm-rf add-ons, debug draw. We don't need this. Okay, so here's what we changed. We don't need that change, so we're gonna undo that. So enemy changed a little bit. Test scenario, we don't actually need that change either. That was just to make it easier to test things. So the only thing we did was we changed the enemy script. So I will push that up and we will get that merged in now that we know that it works. But for now, I'm gonna say thanks so much for coming out to the stream today. It's great to have some company as I do what I'm usually doing in these streams, which is figuring out things. And hopefully next Sunday's stream we will maybe work on some of those other things we were talking about.